Good evening, everybody. I would like to formally introduce myself. My name is Emilia Mandujano, and I will be representing New Mexico State University. But before all, I want you to picture yourself and an angel comes down, Dr. Zhang, and she tells you, Team 1 from New Mexico State, I want you to tell me how I will be able to clean and reuse water due to the limited availability in rural areas in the Southwest. And you look up and down, side to side with past and future technologies, and you nail it down to a trickling filter and multi-layering system. Now, you might say to yourself, what is it? A trickling filter is composed of gravel and plastic material, while your multi-soil layering system is made of 5 layers of 5-inch thick each of activated carbon, walnut shells, iron, zeolite, and sand. And I will explain briefly what each one does. Your soil will take your small suspended solids, your activating will hit nitrogen removal, your zeolite will hit ammonia removal, your walnut shells will remove oil and grease, while your iron will hit phosphate removal. And as you can see in the table next to us, we were able to reach in 7 days all of those tests, allowing us to reach Class 1B requirements set by the EPA. But these also have, in a longer testing period, they will also reach Class 1A requirements. So how does it actually work? Our trickling filter, as you can see in the image, will take the feed water which is your nasty water. They will go into your trickling filter, which here your larger suspended solids will take upon, and they will be removed, creating a aerobic condition for biodegradation. While you will go through a final filtration of your fine named components, where here, once again, you will experience aerobic and anaerobic conditions. But above all, and as mentioned previously, we will remove ammonia, nitrate, and phosphate. Now, why are we working up for this? Because we will prevent possible sewage pollution and exposure to our public, allowing for our city and our people to be safe. We will irrigate public lands such as our streets and be used for fire hydrants and simple stuff like those, but also like flushing your toilet. But the work that we're putting up for, it is because there is a longer service life. The usage of zeolite and walnut are very specific in our components. However, they will have a longer service life because of the following reasons. Right here, as you can see, the service life of all of our components lasts up to 20 years. But yet the mixture of zeolite, carbon, and walnut shells have to be replaced once a year. But that doesn't mean that they will not function. All of the other components within the MSL system will allow us to still reach Class 1B requirements. Now, why do we have to replace it once a year? Now, even though they do have their own lifespan, the natural abundance of these materials will allow us to reduce our cost. Additionally, they will become a secondary treatment or a recyclable material for our farmers. For those who don't know, New Mexico overall depends highly on agriculture. And we want to help our farmers, they want to help us. And the way that we will help them is to give them a fertilizer that will slowly release oxygen and nitrate into our soil. So why Team 1? Because not only will we be achieving water for daily activities, not only will we have materials that are naturally sourced, they're cost efficient and friendly, and they're inexhaustible and readily available, but at the end of the day, you will still be processing 100,000 gallons of water per day. Now, will I accept cash or card?
But for those of you who are joining me for the first time, my name is Jesse Sibley, and this is Nacy Goodson. Thanks, sir. We're from Louisiana State University, and we were tasked with the detection and quantification of microplastics in reservoirs. So let's just take a minute. Microplastics. Up until last fall, that word didn't mean a whole lot to me. It wasn't something I really focused on until we really started doing some research and realized what a problem it is in the environment we live in today. Starting with the contamination that it brings in from the heavy metals and the pesticides as it travels into these reservoirs, then it becomes the problem of the companies that are trying to treat them. Human health is one of the major concerns when treating this sample. You have to deal with the fact of pulling those microplastics out, and the ones that travel through the filtration still may be ingested by humans, causing inflammatory responses and leading to further things that are still being researched for long term. We pride ourselves on being a portable yet effective company. What you see here, we use a very minimal setup. Our bench to scale ratio, we don't have any large vessels that we have to set up in the environment or anything like that. We're a very straightforward design. We use a unique dye protocol, which Nacy's going to talk to you about in a second. We're able to put this on a boat or in your truck, either way, one trip, multiple samples. So in a work day, you're able to load up, take as many samples as you want, get it back to the lab and have your test results within those 30 minutes. So these are some of the test results that we were able to run through. We ran 3, 5, and 10-minute samples, and we were actually, fairly in good ranges. And keep in mind, we're still a very young company. So as we grow, it's just going to get better and better results, hopefully, in the future. So as you can see, from our bench to scale ratio, this is the setup. That was on a 24-foot bay boat with 7 of us in the boat. And we're still able to run the test with enough room for everything to fit in there. Like I mentioned earlier, we're a non-invasive company. We're not disrupting the aquatic life or the environmental life while we're out there. We're mobile, we set up, we get in, we get out in a good time frame.
So Micro on the Go is uniquely green. We use BODIPY 505/15 as opposed to Red Nile, which seems to be the popular choice when testing for microplastics. We are also the most user-friendly portable microplastic detection and quantification method on the market. And by saying that, I mean we have a very user-friendly design that is very easily taught to field techs and requires very minimal setup and takedown. Another thing about BODIPY, it has a higher fluorescence than Nile Red, and it actually has a lower incubation time, which makes it the perfect dye for quick quantification. So there are 84,000 dams in the United States, which means our market is massive. So with that market, we think that we are going to be able to have a total available market of $83 million, $830 million, a serviceable attainable market of just over $41 million, and a serviceable market of just over $20 million. And sorry about that. And with a boat purchase, we stand to make $7,200 annually per location. And the beauty of this is we don't need a boat for every location. So shared boats will bring the profits up to just under $10,000. So as microplastic awareness increases and legislation arises, we plan to be on the forefront of that movement with our product. I sure don't want to be drinking plastic, and I don't think you would either. So we need to make sure that we know what is in our drinking water. We need to call for testing, call your municipalities, call for Micro on the Go. Thank you. So judges, as residents of the Southwest, do you fear for the future of water security? My name is Nadia Stauffer. I am from Michigan Tech Built World Enterprise, and I'm thrilled to present you Sun Sand Pasteurization Water Renewal and all of its potential to solve this very issue. To start, I would like to address the challenge we are faced with in order to form our solution. As we all know, there's increasing water scarcity happening globally due to climate change. However, you might not know it's happening in our very own country. By 2024, 40 states are expected to experience water shortages. That being said, it's time to find opportunities for water reuse. Wastewater lagoons are a common commodity in the Southwest, and our team made it our goal to reuse lagoon effluent to Class 1A or 1B water reuse standards following these water quality parameters. To add complexity to our issue, we wanted to implement our system in small rural communities in the Southwest where it is most needed, therefore needed to be low cost, energy efficient, as well as low maintenance. So after lots of research and brainstorming, we came up with this treatment system of 2 components. The first being a sand and lava rocks mixed media trickling filter that reduces BOD and filters out the TSS and turbidity. Then we have our solar pasteurization system that uses the heat from the sun to disinfect the water and inactivate the coliform. After lots of testing and experimentation, we were able to obtain these results: BOD Class 1A, TSS Class 1B, and reduced total coliform. So here we have our upscale design. As you can see, it starts with our wastewater lagoon effluent being pumped in through our filtration tanks. It then runs through our gravity-fed pasteurization system that is tilted at a 28-degree angle to maximize sunlight. Then we have our heat sensor valves that controls the pasteurization pipe so it can run in batches. We have our heating tanks for backup treatment so the system can run 24 hours a day, including at night. Then we have our storage tank where the water is distributed through a purple pipe system as gray water. Our entire system is relatively energy efficient with only 7 pumps cents per 1,000 gallons of treated wastewater. And that includes the labor rate as well as biosolids handling costs. So impacts. SSP Water Renewal will be able to distribute this reused water to the community for irrigation, household plumbing, and to recreational parks. It also impacts the triple bottom line of sustainability because it conserves water, it uses biosolids, it helps the community save money on their local water bills, it creates a circular economy through the sale of biosolids, and societally, it gives access to clean water, which can essentially improve life quality. To wrap things up, there is no life without water. SSP Water Renewal instills life by checking all the boxes. It's cost-effective, energy efficient, sustainable, and feasible. So rely on sun sand pasteurization to save current and future generations. Thank you very much.
Hi, everyone. My name is Emily McCarty, and I am representing Ohio University's team that is doing task 4, and that is detecting and quantifying microplastics in reservoirs. So right here, you can see a reservoir where it has multiple layers. The metalimnion is the layer where a lot of microplastics end up in the density gradient within the lake. So every day we're all using plastics that eventually degrade into microplastics and end up in our water and in our environment. One issue with this, of many, is that we have a very difficult time detecting and quantifying, so then actually remediating the problem is very, very difficult. So our task was to optimize the design, detect low concentrations of microplastics in a liquid medium, cost effectively, portably, in under 30 minutes, and it was a huge undertaking. So our proposed design solution is an optical detection device that is actually adapted from cell counting. I'm so sorry. That is adapted from cell counting techniques that have been used for decades. So this is something that I actually used back when it was my first semester of college. It's super easy to use imaging software and count the microplastics. So our device is sold as 2 separate packages, and one is an optical detection device and the other is a deep water sampling gear. So like I said, most of the microplastics end up in the metalimnion, which is around 15 meters below the surface. Our deep water sampling gear goes down, grabs a water sampling, you reel it back up on a chain, and then you have your water that's ready to test. There you see the optical detection device, which is actually going to be suction cupped to a table on your boat or whatever surface is available. Water will flow from a syringe in a syringe pump through a flow cell where you can actually visually see the microplastics going through and then going to a final waste collection, and you'll get a video that you can put onto your laptop and actually see the microplastics, and there's video software that can count them. So right here on the left, you can see the flow channel that we designed. It was important that we design one that was different than traditional cell counting techniques would use, because microplastics would stick to those, and there are a couple of other issues with the dimensions. So we created this in our lab after a couple of prototypes. And then here on the right is the channel where you can see a couple of different microplastics in there. So you can get the area, and we have the error that we currently have for our device, but hopefully that will be reduced as we move forward and more R&D is done. So for our implementation plan, we have a 5-step plan that starts with finding investors, continuing research and development, getting a manufacturing site, collaborating with marketing firms to actually turn this into a reality, and then hopefully people can have our device and quantify and detect microplastics. So our overall cost of manufacturing may seem expensive at $4,130, but this is necessary because of 2 main things. One is that everything should be metal or stainless steel, because most other materials will stick to the microplastics. And then the other reason being, we're using a syringe pump, which is expensive, but it makes the error in our results very, very minimal. So 2 main assumptions that we have are market size and market share, but with a 2.5 million small business loan, here are the numbers that we would get for the first 10 years. It would be profitable from year 1, and we would pay off the loan within 10 years. And then overall, we have a device that is portable, it's reliable, and it's great for the environment. And after 10 years of business, we're planning to make over $1.2 million, given all of the conservative assumptions mentioned before. Thank you.
How many of you have an emotional support water bottle, otherwise known as a reusable water bottle? So then we all know after a couple of days of refilling it with your water, drinking it and not cleaning it, it gets a little bit of film, a little bit of gunk. The lip might be a little foggy and gross. What if I told you there was a way to prevent that growth from happening and you don't actually have to do anything? Hi, I'm Mason Bailey, and this is Ann Madison Jones, and we're part of LSU's NASA task, and we're here to tell you a little bit about our project. So currently, NASA uses a system of water recycling aboard the International Space Station. This collects water from the cabin air, from waste such as urine, treats it, and stores it for further use. This system requires an extensive network of pipes, which provides a lot of surface area for bacteria to grow. It also requires a lot of energy input and constant chemical input by astronauts such as iodine.
We want to minimize the surface area of the system that bacteria can grow on. We also want to reduce the amount of interaction that the astronauts need to have with the water system, like i.e. adding chemicals, stirring it, taking care of it, things like that. So the design needs to ensure potable water, safe to drink, save energy, be as low maintenance as possible, reduce the amount of chemicals needed, and last as long as possible without human interference. Our design is called the LOMPR, the Low Maintenance Potable Repository, and it is a two-defense system for two reasons. One of them being that once the astronauts get up to space, they can't exactly run to the store and get new water if this is dirty. Secondly, bacteria actually grows stronger in space, and it can be harder to prevent growth or to kill. So our first line of defense is that the tank is lined with pure copper foil, which is an antimicrobial metal. This prevents bacteria growth. Secondly, we have alternating UVB and UVC lights flashing to kill any bacteria that might grow. This is a rendering of our full-scale design. This is what would be going up into space. It is 12 tanks, each holding 200 liters of water. That's 2,400 liters of water. Each tank has a shut-off valve that can be remotely controlled. Therefore, if bacteria is detected in one of the tanks, it can be shut off, isolating the incident and keeping the rest of the water safe.
Our design insights will allow companies that contract with NASA to further develop that full-scale model. So they can use their resources to discover an optimum dosing time between the UV wavelengths, and they can also choose a metal coating that will extend the lifetime of the copper used in the system.
Let's bring clean water to space to stay.
In a low maintenance way.
Thank you.
By a show of hands, who used this plastic cup at dinner? Who wishes to eliminate microplastics from their life entirely? I present to you the Quantification kit. My name is Jake McDowell. I'm a Michigan Technological University student representing Built World Enterprise. Our research shows that microplastic fragments are found in 39.2% of surface water across the globe. This is an issue today because microplastics cause adverse health effects in both marine life and the human population. As well, microplastic research is inefficient in detecting and quantifying microplastics in real time and in a portable device. I present to you the Quantiplastic kit, a three-step solution to detecting and quantifying microplastics. To begin, microplastics are a hydrophobic material. Therefore, froth flotation can be used to separate microplastics from algae and clay. This is done through aeration, density differences, as well as chemical additives. Next, once the froth accumulates on the top, image-based programming can quantify the microplastics in real time. Lastly, an extrapolation equation is used to give a final concentration of microplastics in items per meter cubed. This is our bench scale demonstration test data that proves that the Quantiplastic kit is a reliable source of concentration of microplastics in water. For this to be utilized on a small watercraft, a peristaltic pump needs to be utilized. This is because the microplastics live in the metalimnion depth due to the change of temperature of every 1 degree Celsius per meter. Therefore, the peristaltic pump will be used to pump it from that depth onto the boat to do the sampling. Next, the device will be in a portable kit, which will allow for a user-friendly experience. In this kit, we have the froth flotation device that has an upgraded look. This look is a one piece of glass that has an inlet for the air, a froth collector in black, as well as a removable lid to eliminate contamination. As well in the kit is a air pump with tubing, as well as microscope accessories. Finally, when you separate those microplastics from the water, you can send them back to us and we will make a sustainable solution, sustainable products like sunglasses or pencils. Finally, we created a 15-month business timeline that includes the pre-launch all the way to 12 months. This includes patenting our product as well as increasing production based on international development and moving forward in a 5-year plan. So our business quote is moving one step closer to solving the macro problem of microplastics. Our ideal customers are university and government research labs that are driven to attack the problem of microplastics. We'll approach our ideal customers through account-based marketing. This will allow us to personalize marketing based on them and really create that one-on-one connection. Finally, we're moving into an environmental monitoring market where the total addressable market is $19.89 billion. The serviceable addressable market is $6.96 billion. And finally, the serviceable attainable market is $4.5 billion. We can produce one Quantiplastic kit for $308 and sell that same kit for $500, leaving us with a profit margin of 27.5%. So why choose us? We strive on building professional relationships with our customers. This is done through one-on-one meetings and surveys to really establish what is wrong with our product and build on that. As well, we have a high employee morale to make sure that life around our company is good and beneficial to the environment. Finally, we are breaking barriers with the microplastic research while still abiding by engineering ethics. Finally, for a 5-year outlook, we plan to continue our research into microplastics, but we're not stopping there. We're going to continue with the environmental monitoring market and continue building new devices. Our competitors are anyone that has already established an environmental research device in the market. Our competitive advantages, we provide a real-time results and a portable system that can be used on the boat, in a stream, on a kayak. It is 4 times cheaper than your average research device that is on the market now, has a longer lifetime value by 3 years. As well as environmental engineers, we like to hit the triple bottom line. So by influencing microplastic research, we help with the health and safety of people and our planet, while also providing more opportunities for environmental research. Our drive, we are 4 environmental engineers that want to see the growth of microplastic research, as well as the collaboration throughout collaboration through researchers across the nation. So I challenge you, I challenge you, make one micro change in order to make a macro difference in our collective future. Thank you.
I thank you all for being here, and I thank those who zoomed in on our webinar, and I hope that you will join us at the WERC Environmental Design Contest next year.